Hello everyone, welcome back to online lecture series on applied thermodynamics. Today we are going to begin a new chapter. So let us just go through our what we have done till date. So here we have completed our first chapter, that is properties of gases. Psychrometry is over. Regarding the third chapter, that is refrigerant and refrigeration cycle, we have completed compression, that is compound compression with intercooler, flash gas removal and flash intercooler, and we are left with the remaining topics that we are going to finish it now, that is in upcoming 3 to 4 lectures. As far as this chapter is concerned, that is fuel, air and actual cycles. So we have gone through the fundamentals of these cycles, so we will be again revisiting this chapter with more details, and we are left with chapter 5, 6 and 7 after that. So as I told you that we are going through the refrigerant and refrigeration cycle. So let's begin. So our today's topic is refrigerant. So it is, so first we will go through the definition. It is a substance which absorb heat from the source which is at lower temperature and reject the same to the sink, which is at higher temperature. So that is known as refrigerant. and this will be done, this absorption will be done either in form of latent heat or sensible heat. So here the refrigerants which does the refrigeration, that is absorption of heat in form of latent heat, are more efficient than those who do the same task with sensible heat. Now we will go through the classification of refrigerant. So here we have classification in two ways. First is primary refrigerant, and second category is secondary refrigerant. So here the thing is that in primary refrigerant, the refrigerant directly takes part into the refrigeration process. That is, this refrigerant itself will absorb the heat and reject it into the sink. However, in case of secondary refrigerant, these secondary refrigerants are first cooled by the primary refrigerants and then used for the cooling purpose. So again I am repeating this part, I am not writing down here, that in case of primary refrigerant, they directly take part into the refrigeration, and secondary refrigerants are first cooled by the primary refrigerants and then they are used for the cooling purpose. So this is the classification here, and now we will see further classification of primary refrigerants. So here first is halocarbon refrigerants, then we have azeotrope refrigerant, Then we have inorganic refrigerant, and after that the last one is hydrocarbon refrigerant. So this is all about the classification of refrigerant. See, there are few details are there, that is there are some description on this, but I will leave it up to you as a part of self study, because those small details we are not going to discuss here. Now we will move forward with more important topic, that is designation of refrigerant or nomenclature of refrigerant. So here, now let's focus on this part. So we will first note down the general chemical formula. That is, it can be said that this is CM HN Cl P and FQ. And in this case, one important thing that we need to remember is N plus P plus Q is equal to 2M plus 2. Here M is equal to number of carbon atoms. N is equal to number of hydrogen atoms. Then P is equal to number of fluorine atoms, and Q is equal to number of fluorine atoms. And the designation that will be done will be like this, that R M minus 1 N plus 1 into Q. So now what we will do is we will take, I think we are going to take 3 examples here, and we will end this lecture with 3 examples of how we can designate a refrigerant. So our first example is dichloro difluoro methane. Okay, so this is our first example, and let's start. So now number of okay, we need to keep this alive here. Number of chlorine atoms are 2, so P is equal to 2. Dichloro means chlorine atoms are 2. Then difluoro, so fluorine atoms are also 2. Then number of hydrogen atoms, that is N is equal to 0. So now we will apply this equation, that is, let me write down that N plus P plus Q is equal to 2M plus 2. So here N is equal to 0 plus 2 plus 2 is equal to is equal to 2M plus 2. So finally what we will be getting here is M is equal to 1. So if we see this equation, here we are having C1 H0 Cl2 and F2. So in a better way we can write down this as Cl2 F2. Now regarding the nomenclature part, so let us write down the answer now. R M minus 1, that is 1 minus 1 Then we can write down n is 0, so 0 0 plus 1, and q is here in this case 2, so we can write down this as r 0 1 2, and in a better way we can write down r 1 2. Okay, so we are done with this. Now let's move forward with our next example, that is second example. Dichloro tetra fluoroethane. So in such case we can say that dichloro, that is P is equal to 2, tetrafluoro, that is Q is equal to 4, and it is ethane, so here N is equal to 0. So again we will begin with the fundamental equation, N plus P plus Q is equal to 2N plus 2. 2 plus, oops, it should be 0. 0 plus 2 plus 4. So here it is equal to 2m plus 2. So we can cancel this, and here we will get 4 is equal to 2m. So m is equal to 2. So here now we can write down this C2 H0 Cl2 F4. So we can further write down this as C2 Cl2 F4, and the final answer will be like R m minus 1, that is 2 minus 1, then n plus 1, that is 0 plus 1, then q, that is 4, is equal to R 1 1 4. So that is the designation for dichlorotetrafluoroethane. Now our third and last example of today, that is third example, difluoro monochloro methane. So now in this case, dry fluoro means Q equal to 2 here, then monofluoro, that is P is equal to 1 here, hydrogen atoms are here 1, N is equal to 1, and we need to calculate, we need to obtain this R formula. So again N plus P plus Q is equal to 2M plus 2. So 1 plus 1 plus 2 is equal to 2M plus 2. So M is equal to 1. So finally what we are getting here is C1 H1 Cl 1 F2. So we can write down this as CHCl F2. Now regarding R, M minus 1, that is 1 minus 1, N plus 1, that is 1 plus 1, and last one was Q, that is here we are having Q as 2. So the answer is R double 2. So these are the 3 examples, and now we will copy this work into our slides. So we are done with today's lecture. So let's do a quick revision of what we have done today. So today we started with the definition of refrigerant. We also discussed about classification of refrigerant, that is primary and secondary refrigerants. This part I have given you in form of self-study. Then the designation of refrigerant was our next topic. This is the chemical formula CmHn ClPFQ, and here this is N plus P plus Q is equal to 2M plus 2, and the final designation is like Rm minus 1 N plus 1 Q. We also discussed about 3 examples today, and now we are ending this lecture here, and in our next lecture we will discuss about the desirable properties of ideal refrigerant. So this is the end. Thank you for watching this video.